There's some differences in helicopter than there is in aircraft. As we proceed with this module, we're going to start to talk a little bit about helicopters. We've done a lot of fixed-wing aircraft, now we're getting into helicopters. We're going to see how much more restrictive the helicopters are than the fixed-wing aircraft. We're going to learn about the butt line and about the latitude and how that, we didn't care about that so much on a fixed-wing aircraft, but like I said, the center of gravity restrictions on a helicopter are much more restrictive than a fixed wing. So as we get into this module, we're going to review some terms that you may not be familiar with, but hang on, this one's going to be fun. The weight and balance, the concept is the same. How we calculate the center of gravity is the same. However, in an airplane where you have 18 to 24 inches to keep that center of balance in, that helicopter, everything hangs right off of this little guy right here, that little rotor. Okay, he's really hanging off of there. If you don't have that aircraft properly weight and balanced, if it's a little bit forward, a little bit aft, when he's in a low hover, that airplane is going to get very, very unstable for him. If you notice, everything in that helicopter is underneath that pendulum. The fuel tanks are under the pendulum, all the crew is under the pendulum, everything is right under that center. So when you look at a helicopter, we're talking about maybe 2 inches forward or 2 inches aft, 2 inches left, 2 inches right. Remember, on the airplane, we didn't care too much about left and right. We cared forward and aft. On a helicopter, we're worried about left and right or forward and aft. It's just that much more critical. When weighing a helicopter, we need to know the longitudinal and the lateral weight points of the aircraft. Again, longitudinal from the front going back, and lateral is left and right. We need to know what the arms, we need to know where we're going to measure the airplane from. What is the datum on that helicopter? We also, when we're doing the weight and balance on a helicopter, we have to read the type certificate. We need to find out, how do I position that main rotor? Where should that main rotor be when I'm actually doing the weight and balance of that aircraft? Some aircraft, when I did my, remember I did my small Cessna 150, and I used my propeller protractor here to get to balance my helicopter, to get it level. I used that propeller protractor. I could use that, I could have used a Spirit level. We talked about some of the other airplanes that had screws on the side of the airplane, and you'd put a Spirit level on there, and you could get it forward and aft, you could get it level that way. Well, on a helicopter, if you're not using the Spirit level, you could be using a plumb bob. Helicopters are kind of neat in the fact that they have a plate right down in the center on the bottom of the helicopter, on the bottom floor, if you will, okay? And the plumb bob attaches up to the top and hangs down. And it hangs down, and you can look and see on the floor of the aircraft, there's a set of crosshairs. And you want that plumb bob to come right down and hang, and actually the tip of that plumb bob should come down and actually intersect where those crosshairs are. If it's forward, then you need to jack the nose of the helicopter up. If it's too far aft, you need to let the helicopter nose down just a little bit, but you need to back and forth to get that right dead center. Once you get it forward, longitudinal, or lateral, then we're going to have to go longitudinal left and right. We're going to do the same thing. Do we need to bring the left gear up or the right gear up? Which one do we got to bring up? We've got to get it perfectly balanced. Again, helicopters are so much more restrictive than fixed-wing aircraft. The Jet Ranger helicopter, again, we're going to use that little target, if you will, that's on the floor. We're going to use the jack pads, 2 in the front, 1 in the back, so that we can get that helicopter perfectly balanced. We're going to have the load cells that go between the helicopter and the jacks. That's how we're going to use this one here. Remember that little Cessna 150 we rolled up onto the scales, and we actually weighed it with the scales. Well, this one here, we're actually going to use the load cells that go between the jack and the fuselage. Going to get the exact same information, left jack, right jack, tail jack, and we're going to use that to calculate our weight and balance. On this particular helicopter, we've got a datum. The datum for the forward jack point is 55.16 inches. That means that it's 55 inches or 55.1 inches aft of the datum. Some helicopters, this one here is one of them as well, that datum, notice, is just a couple inches forward of the nose of the aircraft. So that all of our measurements are now going to be positive. Anything that we add weight-wise, anything after the datum is a positive number. So we're not dealing with positive and negative numbers with this helicopter right here. We're going to take into consideration the fuel and the oil. We're going to drain the fuel, fill the oil. We're going to look at the scales. Notice our left scale is 650 pounds. Our right scale is 625 pounds. Again, there's nothing that says that those scales have to weigh the exact weight. The arm for where they're going to be at is the same, and the moment could be different because the weight of each scale is going to be slightly different. The chart here for calculation, we have an empty weight of 1,985 pounds. The longitudinal center of gravity is 108.73 inches, and the lateral is a minus 0.31, or it's just slightly off of centered. So when we look at our front scale and our rear scales, our aft scale, each one gives us a weight. Notice I have no tare weight. What was the tare weight again? The tare weight was stuff that we were going to need to leave on the airplane for the weight and balance, but we wouldn't normally fly with. On this particular configuration, our tare weight was 0. We do all the scale, we add up all the scales, we come up with 1,985 pounds. We come up with a moment of 215,822.2, and then I can figure out that my center of gravity, my longitudinal CG is 1,985 inches aft of that datum. So if I take this datum right here, and I look at where the datum is right here, and I go aft 1,985 inches, that's where my center of balance is going to be. And I can pretty much guarantee it's going to be right underneath that main rotor hub. That's pretty much where we're going to want that CG range. Okay, so by this point, as we summarize, you should be really aware of the fact that the center of gravity range in a helicopter is much more restricted than what we found in the fixed-wing aircraft. We're more concerned about left and right and forward and aft, whereas a fixed-wing aircraft, we were more worried about forward and aft. Hopefully by now, you should be able to safely calculate the center of gravity of a helicopter.